we are finishing up section 3, probably going to start into that activity 4. We are on problem 5, and in some of my classes I was able to get to part of this problem, but I'm going to go over it again. So a set is a collection of items. So you guys have seen sets all your lives. Like I told one class or on the video yesterday, my kids are really into Disney pins. So you go around, you trade them at Disney, little cast pins, and you can come up to them and you can say, I'll take this pin for this pin. You guys know what I'm talking about? Well, they have sets of those. And so, like, my kids just discovered that. My daughter saw, like, a Mickey car one, and she thought it was really cool, so she grabbed it. She was, a couple days later, was going around, and she saw one that was a mini one. And she's like, oh, Dad, they must have a set of this. They must have made a whole bunch of the characters into these little car-looking figures. And so we looked it up, and she found that there was a set. And she looked at the pins that she was missing. And now whenever we go to Disney Springs or any of the parks, she's looking for that set. And they have a couple different sets now going that they really like. My son loves a cupcake. They have little cupcakes. He also likes one that has Star Wars. So those are kind of sets. You guys grew up with Pokemon cards or something like that. You can collect a set, which means you have every card that they made for that series. And it's been around forever. They've had Magic cards, baseball cards. Topps in 1998 made maybe 375 cards. If you have all 375 of those cards, you have the complete set. Okay? So that's kind of what a set is. It's a collection of items. Okay? So then, and if X is a member of the set, if you have a card, right, and that's a member of the set, then X is an element. So member of the set is called element. Now, 2 or more sets are disjoint sets if they don't have anything in common. And they're going to come up with some examples down there. But something that I think is a little more real is if I was talking about my Disney pins, that's a set, correct? And my Pokemon cards, that's a set too, but they're disjoint. You're not going to have a Pokemon card that's also in the Disney. Does that make sense? Now, 2 or more intersecting sets if they have a common element. If I gave you a list back in the day of all the baseball players, and I gave you a list of all the football players, there actually were people. There's a guy named Deion Sanders. The reason I know is because I love his baseball team. He played for the Atlanta Braves, the team that I grew up watching because the Rays weren't around. So I grew up and I've always been a Braves fan, and now I currently root for the Rays, but the Braves have always been my favorite team. He played for them. Well, he also played for the Atlanta Falcons. He played on both football and baseball. So, do those 2 lists share an element in common? Yes, Deion Sanders would be on both the football list and the baseball list, so those are intersecting sets. Does that make sense? And then give you some school-related ones where there's, the 9th grade student list, the 10th grade student list. There shouldn't be any kids that overlap. Either you're in 9th grade or you're in 10th grade for, like, our point. There is no in-betweens. I know some of you, for credits and stuff, no, that's not really on a list. You have to have this many credits in order to be a 10th grader. If you don't have that many credits, you're still in 9th grade. Does that make sense? Okay. Intersecting set, they say that this girl is on the volleyball team. She's also in the math club. So the volleyball team and the math club are intersecting sets because of Julie. Does that make sense? Questions on that? All right. So identify the sets in scenarios problems 1 through 4, then determine whether the sets are disjoint or intersecting. So remember my holes that I said? Do you remember I said for the pizza you have 4 holes to fill? That's going to help you out with this, right? Because look, if you look, it says the pizza special has how many sets? 4, because they had 4 things that we needed to fill in, right? Now, was this set, did this set, this set, this set, and this set, did any of those share any of those things in common? No. Pizza size was what? Small or large? Was small or large in the pizza shape? No. What was in my pizza shape? Round or square? Type of crust was thick or thin. Toppings were pepperoni or mushroom. So were any of those sets intersecting? So we called those disjoint because they didn't have any common elements. In our student council one, how many sets did we have? How many holes did we have to fill? 2. President and vice president. Were those sets intersecting or were they disjoint? They were intersecting because the list that I had for president was also the same list that I had for vice president. So those are intersecting. Do you guys see this? Is it making sense? What about for my front day? My favorite one. Oh, I'm sorry, cafeteria first. Were any of those intersect? How many sets did we have? We had 3. We had an entree. We had a side dish. Who could forget those desserts?
Cottage cheese.
Cottage cheese or granola bar. Then this set is disjoint because there's nothing in common with those guys. It wasn't, you could have fish for an entree or you could have fish for a side. Okay, there was nothing like that. You following me? All right, frozen yogurt, 3 different sets. Disjoint, they didn't have any common elements. All right, next thing, independent events. Independent events are events for which the occurrence of one event has no impact on the other. So like, if I told you, if I said, you know what, today I'm going to order a large pizza. Does that automatically give you a hint that, you know what? That means he's probably getting pepperoni. Did me getting a large have any effect on the topping that I picked? Not at all. Did it give you a closer, better clue of what I was going to pick? No. Does that make sense? Now, dependent events are events which the occurrence of one event impacts the occurrence of another. Did the frozen yogurt have any dependent events? When a person gets vanilla, they have to get sprinkles. No, there's no such thing. No, it doesn't matter, right? Now, let me ask you about for the president. When I chose the president, did that affect who could be my vice president? Yes, because once I picked my president, their name was removed from my list, so it impacts who my vice presidents can be directed. Because we said once you pick a president, they can no longer be your vice president, so the president affects who is going to be for a vice president. Does that kind of make sense? All right, independent events. You barely choose. So a jar contains a blue, a green, and a yellow. 2 yellow marbles. We talked that we were going to do this situation. Do you guys remember me saying this? You randomly choose a yellow marble, replace the marble in the jar, and then randomly choose a yellow marble again. Okay? The event of choosing the yellow marble first does not affect choosing the yellow marble second. Why? Because you put it back in. Does that make sense? When I put my yellow marble back in, I have the same chance of pulling it the second time as I did the first time. So no events changed. You with me? Now, this is again why this is tricky. And I've said this, it's not hard. Remember, hard is something that no matter how much you practice it, you're probably still not going to be successful. There are things like that in life. Sorry. Hitting a baseball at 95 miles an hour is one of the ones I always go to. That's why those guys are professionals. That's why there's very few and far between who make it to the big leagues. Because it is hard And there are people who put hours of practice in, and they still can't accomplish what needs to be done. This is tricky, which means you need to take your time, but everyone can accomplish this and get this done. Do you see the difference between the two? Here's why it's tricky. They just change a couple words up here, and it changes your perspective of the problem. Now they say, hey, you take a yellow marble, but do not replace it. Does that affect your chances of pulling a yellow marble for the next time? Yeah, because now I had a 2 out of 4 chance of pulling it, right? A 50-50 shot. Now when I don't replace it, I have a 1 out of 3 chance. My percentage changed. That means that my first event is affecting my second event. Does that make sense? Okay? So here's all the... So, dependent. Notice what they said. You randomly choose a yellow marble without replacing the marble in the jar, and then randomly choose a yellow again. So do you see how they're telling you the situation? They're going to tell you, here's what happens. You're going to pull a yellow. Second, you're going to pull another yellow. What are the chances of that happening? That's kind of the scenario. They're giving you the event. The event in this case that we're reading right here is what? Choosing a yellow marble and then choosing another yellow marble. Remember, an event doesn't just have to be one thing. It can be a set of a couple of them happening at the same time. Does that make sense? Okay? So, does everybody understand this independent versus dependent variable thing? Or events? Yes? Alright, let's see what they're trying to say here. I think that choosing the first marble, choosing the second marble are dependent events. Okay, they're just being very, very particular. Okay, look at what they're saying. They're saying that her statement is incorrect because choosing the first marble and choosing the second marble are actions, not events. Choosing a marble first and choosing a marble second are events. In general, events are more specific than actions. So the outcome for choosing the second marble are affected by the outcomes of choosing the first marble. So very subtle difference. I probably won't be too particular as long as I can understand what you're saying. But do you get what they're showing you here? Alright. Identify one outcome from each scenario in the problem. State whether that event, result, the outcome are independent or dependent. So one possible outcome in the pizza is a large, square, thick crust pizza. So this is an outcome. This is one of the things that the person could order. Do you remember we made a list of them? And they chose one, I think there were 16 of them if I remember correct, right? Okay, they picked one of the 16 outcomes. Now, are any of these events dependent on the other one? No, we said it doesn't matter if you order a large, it doesn't affect whether you get a pepperoni. So they're individual events. Does that make sense? Yeah. So these are independent guys. All right, student council. The two individual events of electing Gwen president and electing Miguel vice are dependent because the event of electing a president affects the event of electing a vice president. If Gwen is president, she cannot be vice president. So we talked about this already. You with me? Okay? So we've already done all these guys. We've already talked about that. All right, this guy is what we've already kind of gone through. To determine the total number of possible lunches in problem 3, Paulo uses a math principle called the counting principle. The principle is used to determine the number of outcomes in a sample space. This is already what I have showed you with my holes and how many of them and having to multiply them. This now has a name. It is called the counting principle. So when you hear counting principle, you are trying to figure, if it says use the counting principle to find out, you're trying to find out how many different options would there be in this scenario. Are you following? If you use the counting principle, can my number be really big? Sure, because you're only supposed to what? Multiply to get that. Do you have to make a list of all of the different outcomes and then count them? No. This is to help that. The principle states that if action A occurs in m ways, and for each of the m ways an action B occurs in n ways, then A and a B can occur in m times n. They make it sound more difficult than the first. Remember the way I did it. How many holes do we have? How many ways do I have of filling the first one? How many ways do I have of filling the second one, the third one, and so on, and then multiply them all together. Does that make sense? Okay? So, Devin has an all-day pass for Scream Music. His favorite rides are bungee, head rush, Jeep go-karts, tsunami slide, water roller coaster. He sounds great. He never rides any of the other rides, and he can ride each of his favorite rides as many times as he wants. All right? So, describe the type of events for selecting the ride order. Does this situation involve independent events or disjoint sets, independent events from the same set with repetition allowed, or dependent events with sets without repetition? So, this situation involves independent events from the same set. Okay? They are independent because one ride selection does not affect the next ride selection. If he rides the bungee one, does that mean he can't ride bungee again the second time? You with me? Because once he rides bungee, he can ride bungee again if he wanted to. That right after. Right? Okay? So repetition is allowed. Lastly, all of the choices are from the same set. Devin's 4 favorite rides, right? So like, if I made a list and I go, okay, here's his ride selection. He's going to ride 1, 2, 3, 4, 5, 6, 7 rides. What are options for the first ride? Well, 2, 3, 4, right? Those are the 4 options. Those four options could go here, correct? You with me? Where does this next set come from? What are the options of him riding rides? They're still the same set. That's what they're saying, right? It comes from the same set. Now, because he chooses bungee, can he choose it again the next one? Yes, because they said he can re-ride the ride. So again, we still have 4. And this is independent. This right here is independent of this, because just because he rides this one doesn't mean it changes his ride selection for the next one. You following? Okay? Now, it says use the counting principle to, if Devin chooses for his next 2 rides. Well, how many holes do we have to fill?
4.
How many holes do we have? No, this is my problem. Sorry. My problem. Let's read their problem. Use the counting principle to determine the number of possible rides for Devin's next 2 rides. How many holes do we have to fill? 2, right? His next 2 rides. How many options does he have for this one? 4. How many options does he have for his next one? And so how many different orders could there be? 16. Does everybody see where this is getting? They're getting this from. Next 5 rides, how many holes do we have to fill? 5, yes? So then you got 1,024. Does everybody see where this is coming from? Sherry stayed home from school Wednesday because she was ill. Sure she was. She watched it. Oh, she can watch TV. From 12 until 12:30, and another program from 12:30 to 1:30. From 12 to 12:30, her program choices were news, cartoons, or talk shows. From 12:30 to 1, her program choice was comedy, soap opera, game show, hopefully it's The Price is Right, or a slow cooking show. I mean a cooking show. I don't know why it's slow. And my fault cooking show people. Alright. Describe the type of event Sherry's television program selection. So how many holes does she have to pick from? Or how many holes does she have to fill? She has to fill 2, right? Yeah. She has to fill her time from 12 to 12:30. That's 1 show selection. And what's the other one? From 12:30 to 1 o'clock, yes? So she only has 2 holes that she needs filled. Now, what happens, how many choices does she have for her first one? 3. How many does she have for her next one? Is it 3 or 4? So how many different options could she put together to find, like, she's got 12 different options that could happen. Now, is this, or this, are they dependent on each other, or are they independent? Are they from the same set, or are they different sets? So are they disjoint or intersect? Disjoint, because there's no programs. Now, all they had to do is put cartoons down here in this second one, and then they would be intersecting, but they don't become dependent. Do you get what I'm saying? Now, unless she's really crazy fanatic fan, let's say that this one TV show is running twice in a row. Let's say it's the new one, so you've seen them do that, correct? Where they run it at 12, 12 to 12:30, and then from 12:30 to 1 right again, just in case they wanted people to see that. They used to do that a lot more, especially when we didn't have the ability to record TV. I'm aging myself. When there was a new show that came out, they would rerun it a couple times, just in case people couldn't be home at 5 o'clock. You with me? Now, what if she watched that show the first time? She doesn't want to rewatch something, and that same show is still in this section. Now, would these 2 events become dependent? Do you get what I'm kind of trying to show you? Yeah. Okay? So, alright, so here we go, this is a good one. A student's daily schedule includes math, English, science, social studies, a foreign language, or physical education. Students enroll in each class for 1 period a day. Does that sound correct? Yeah. Okay. Describe the type of event. So when they say describe the type of event, they're asking us to tell us the stuff that we know. The situation involved dependent events. Why? Well, I can't, so once I pick math, so I've got, how many holes do I have to fill? Is that what they say? Yeah. 1, 2, 3, 4, 5, 6, 7. Oh, wow. 1, 2, 3, 4, 5, 6, 7. So once I fill this gap, does that affect this gap that's here? Yes, which is why it's hard to build a schedule. Can you imagine being those guidance counselors? Yeah. You have to do 1,000 different kids, and you've got to make all the different schedules to work together, and we can't have 45 kids in this one class. So they've got to make sure that they keep within their limits of how many kids are in their class. They've got to build so they have to keep moving these things around and switching a schedule. right? They've got to keep playing with this, but they can't, their sets are intersecting and they kind of depend on one another. If I change one kid's schedule, it can affect somebody else's. You with me on this? So, there are dependent events because what I choose here, this event depends on what I choose here. Once I choose math, I can't choose math here, so this one depends on what I put for my first period. That they're same sets. That means that I'm using this same set every time for all of these gaps. I'm choosing from the same ones. You with me? Can we have independent events that still choose from the same set? Yes, as long as what is allowed. What was Devin? Why was Devin's? Because he could choose the same ride over and over again. So what I choose for my first ride didn't affect what I choose for my second one. But because there's no repetition, and I'm picking from the same set, that means these are going to be dependent events. You with me? Now the situation is dependent because once a class is taken, a student cannot take the class a second time within the same day. We know there's exceptions to that, but the events are from one set of the 7 classes. So determine how many different orders of classes can be arranged. So what's going to go in this gap? 7, 6, 5, 4, 3, 2, and then 1. Correct? And so if you multiply that out, there's 5,040 different ways of scheduling one student. Does that change your mind on how tough that must be to go through as a guidance counselor? One student, there's 5,040 different ways of arranging their schedule. And you know what we didn't even throw in? There's different teachers. There's different classes within math, right? All kinds of things. Exact honors, all that kind of stuff. So it's nasty. Does that make sense? We're just keeping it simple for this. So lunch is directly after 4th period. How many different class schedules can be arranged are possible before lunch? Okay, so before lunch, how many holes are we filling in this time? How many options for this one? This one? 5, 4, yes? 840 different ways. Do we understand this counting principle? Okay. Cell phone PIN access is a 4-digit. Each digit can be from 0 to 9, including 0 and 9. Now that is definitely tricky. That is definitely tricky. How many numbers are from 0 to 9? 10. Why is it tricky? What do you think most kids want to put? 9, because we're not used to including counting 0. You ever done that with like a little brother or sister? They're in, yeah, right? You can start 1, 1, 2, 3, 4, 5, and then you're like, no, there's not. It's 0, 1, 2, 3, 4. There's only 4 here. It blows their mind. We don't count with 0. So that is the tricky part. And this one, again, tricky, not hard. You just have to pay attention to the wording. All right? So how many different digits are possible for 4 digits with repetition? So you remember your little cell phone when it's locked? You're going, come on, how many different ways can there be of making this? Well, 10 times 10 times 10 times 10, because with repetition allowed, just because I picked that first number doesn't mean I can't pick it again. You with me? Now what happens when you're not allowed to repeat a digit? Now you got 4 holes to fill. Now you only have 10, then you only have 9, plus you, then 8, and then 7. Because once you pick a number, you can't choose that number. Still, there's 5,040 different ways of arranging. You with me on this? Yeah. You ever wondered why you can have a license plate and how they can have all the license plates and not repeat them? Well, look at the license plate and it consists, now this is not true, because we know that we can have letters or numbers basically anywhere, right? So with ours, if you look at this, you would have to take the numbers. How many numbers are there in the alphabet? How many digits from 0 to 9? So how many, if I can have a letter or a number in this slot, how many options are there for me in this slot? You have to add, how many letters are there? How many numbers are there? How many options are there for this slot then? For ours in Florida, from what I believe, we can have letters or numbers in any of the slots. You can have 36 different options for the first slot. You can have, are we allowed to repeat? 0, 0, yeah, absolutely. So, you would have 36 times, and then also you would have to add this because do license plates have to be 7 digits? You ever seen someone who has like their name spelled out or whatever, and the first one they get it?
It's not my first name. I say 3. My mom and dad are safe.
But do you have 7 letters on it or 7 things on it? No, characters. No, because you're allowed to have. So we would have to figure out how many options there are for 7, how many different options there are for 6, how many different options there are for 5, and add all of those together, and that's how many different license plates are available. Now, does it make sense why we can have license plates to tell us whose car this is? Because before, I know when I was a kid, I'm like, how? There's no way.
Yeah.
There's no way. What about Social Security numbers? You're going, come on. How in the world does everyone in America have their own Social Security number? Because it's numbers between 0 and 9. Your Social Security number is 8 long, right? So you've got 10 to the 8th power of how many different options there are for making a Social Security number. Does that make sense? Same with phone numbers. Well, what do they? So back in the day, right? We didn't always have 727. When we start getting more people, what do we throw in there? We throw an area code in there because then we get 3 more holes to fill with 10 more options. You with me? So then, boom, now my numbers jump up to where I can accommodate all the people. So they just go through all these different scenarios. Does this make sense?
Yes.
Now, this right here, difference between these two, this one, they can repeat. Once they get here, they say it can't repeat, so your options go down, right? So 10, 10, 10, 10, well, this was 10, 9, 8, 7. And you can see how greatly it affects. Look with that repetition, how many options there are. Look at how many without the repetition, how many options there are. Big difference, correct? I think we're finished with that section. We'll pick up on section 4 tomorrow.